The perfect end to a dinner party. A sharp knife slices through a delicate crust, releasing a warm, rich stream of liquid chocolate. But a flawless lava cake relies on strict, tested parameters. The standard recipe calls for a 2-liter capacity bowl, 72% dark chocolate, and exactly 50 minutes of bake time. So what happens if you throw those volume limits out the window and attempt to scale that exact same recipe up to 50 pounds? Successful baking relies on a synchronized chain of physical, chemical, and heat transfer processes occurring simultaneously. History shows us that pushing chemical and biological processes past their established limits routinely turns food into a hazard. In the winter of 1971, a massive shipment of grain arrived in Basra, treated with a toxic methylmercury fungicide. When safe handling protocols failed, the poisoned grain entered the food supply, leading to 459 deaths. Multiplying ingredients without mathematically scaling the movement of heat and moisture transforms a simple kitchen project into a volatile industrial hazard. 10 minutes into the bake, our 50-pound mound of dense batter sits inside a 350-degree oven. A heat gradient forms. Radiation heats the outer edge, while the core remains cool. Crossing 100 degrees Celsius, surface water evaporates, baking the boundary into a solid crust. This shell traps expanding vapor. Gas pushes outward, while some forces backward, condensing in the center. We have already seen what happens when industrial-scale pressure vessels fail. We only have to look at Boston in 1919. A giant tank holding 2.5 million gallons of molasses succumbed to unmanageable internal pressure. The container exploded, leveling the surrounding working-class neighborhood. A 15-foot-high wave of thick syrup crashed through the streets at 35 miles per hour, destroying elevated train tracks and enveloping everything. That structural failure was driven by the exact same physics playing out inside our 50-pound cake. An unvented, massive volume of water vapor is building against an unyielding exterior shell. At the 60-minute mark, the sheer mass of the giant cake means the core is still raw. To cook the center, we have to keep baking. Extending the time strips all remaining moisture from the outer layers of the cake. They scorch and dry out completely. Flour and sugar are carbohydrates. When they are deprived of moisture and exposed to high heat, they become highly combustible. For a case study in carbohydrate combustion, consider the Washburn A Mill in Minneapolis. In 1878, it was the largest flour-making facility in America. Inside the facility, grinding stones generated a simple spark. The spark found a rich fuel source, thousands of microscopic, bone-dry flour particles suspended in air. The resulting explosion instantly killed 18 people and triggered secondary fires that leveled 6 neighboring mills. By overbaking to heat the core, we have sealed scorched flour and sugar inside the crust. We perfectly replicated the volatile, highly combustible fuel conditions of the Washburn Mill inside our oven. The timer finally rings. Inside the oven, the thermodynamic stress has reached its absolute limit. The structural integrity of the cake finally fails. The massive internal vapor pressure violently breaches the hardened, intensely scorched crust. This sudden depressurization acts as an aerosolizer. It blasts dry, unmixed pockets of flour and sugar directly into the superheated 350-degree oven air. The suspended carbohydrates rapidly ignite. A thermodynamic explosion rips through the confined space, blowing the heavy metal doors completely off the oven. What follows the blast is a slow-moving, deadly wave of boiling, raw liquid batter pouring out from the wreckage. It mirrors the 1814 London beer flood, where corroded brewery vats burst, sending 3,500 barrels of heavy porter crashing through Tottenham Court, knocking down walls and flooding the streets. A recipe operates on strict engineering parameters, dictated by the laws of mass diffusion and heat transfer. When you scale up the volume and ignore the physics, everyday baking ends in industrial disaster.